you understand it completely.
That's what I meant.
Okay. So, when we are graphing piecewise functions, always start in the upper right.
Okay.
Right here.
Okay.
So the very first thing we care about is what happens when x is less than or equal to minus 1. Well, let's put minus 1 on there.
Okay.
And then I'm going to draw a solid line through that because the first part of our graph occupies this area right here. You with me?
Yes.
Okay. So the graph I want to be to the left of that solid red line is x squared.
Okay.
Well, what does x squared look like? Normally, x squared looks like this.
Right.
Parabola. But there's two ways to do this. One way is to draw the entire graph and then erase the part that you don't need. In other words, it's only this graph to the left of negative 1.
Okay.
Okay? Which means the graph, I'm going to erase it like that, and what I have is this part of it left with a closed dot right there because it's less than or equal.
It's a negative.
Now, that's one way to graph this thing. And then the other way is y equals x. If x is greater, well, that's merely a straight line. Goes through the origin and continues to there with an open circle.
Okay.
Okay. Now, that's kind of the hard way to do this. You don't want to have to graph the entire thing and then erase part of it. But it's a good way to look at it. This is a curved line, incidentally. This is part of a parabola. This is a straight line over here. This is a parabola. The better way to do this is to let's figure out what the coordinates on that thing are right there. What are the coordinates at that point?
The coordinates of that point would be -1, comma. Is that like supposed to be like a 0, or is that positive?
What's the y coordinate going to be? Remember, y is the same as g of x. So plug in -1 for x and solve.
So it'd be 1, right?
Yeah, which means that if we want to plot this thing, we don't actually have to plot the entire parabola and then erase part of it. We can start at the key point, which is the line of demarcation, or whatever you want to call -1. -1 is what separates the vertical line. -1 is what separates this thing into two pieces. Okay? So if we can figure out what's going on exactly at -1, then we can start the process, and it's a little easier to do. Well, if I start here and work backwards, I know I have a parabola that's going to look like that, and I've got all the key points. It's a parabola. In other words, here y is equal to x squared. And now, to plot the rest of it, I also don't need to go through the origin. I need to figure out what that point is. And it's an open circle because it's greater than.
Right.
Well, when x is -1, what is g of x?
-1, it would be -1.
Also.
Right.
That's a circle. It has slope of 1. Do you see why the slope is 1?
Yeah.
Because y equals x. So if you think about it as y equal mx plus b, b is -1, slope is 1, so it's going to go up at a 45-degree angle.
Okay.
And that's how you plot piecewise functions. And if you're going the other way, where they give you the drawing and they want you to come up with the equations, do it the exact same way. In other words, if I'm looking at this drawing, here, this is a little confusing. That's the y-axis, that's the x-axis. But if I'm looking at this drawing, I'm going to start from negative infinity. Always going to start on the far left, and I only have one function that defines that entire space. And that's y equal x squared, but only when x is less than or equal to negative 1. And this function here, there's only one function that describes that, which is y equal x. But only when y, or when x is greater than negative 1. So always work left to right when you're going this way, and when you're going from here to graph, you're also working left to right, but you're starting in the upper right. In other words, this is the domain here.
Okay.
Okay.
So the domain would be negative 1 to infinity?
What's the domain of the whole function?
Negative 1, right?
What's the very left side of this domain?
I am so confused.
Negative infinity.
Okay.
Start from the far left and go to the right. So if I'm looking at this set of points here, x being less than or equal to negative 1, I got to start at negative infinity and go up to negative 1. So the domain of this is negative infinity to negative 1. The domain of this is 1, or negative 1, to positive infinity. So the domain of the entire function is all real numbers. There is no value that x cannot be.
Okay.
As long as they have this point, negative 1, covered. In other words, take away that equal, make that less than negative 1, and make this greater than negative 1. And now all of a sudden you have a point that x cannot be. It cannot be negative 1. But in this case, since one of them was a less than or equal, and the other was a greater than, we've got all points of the number line covered between those two statements.
Okay.
Now, this is a little harder because it's a three-piece function. You want to do 35? How about you do 35? And we'll see if you got it figured out.
All right. So
here I'm going to draw the XY axis.
Right. And
where are you going to start?
I'm going to start on like
right there.
Right.
The upper right. In other words, where we're going to start is our domain, and we're going to always go left to right. And the way you do that is, here's the domain over here, and since I'm going left to right, the first area I'm concerned with is what? What's that area right there?
X is less than 0?
Yeah, which is everything left of the y-axis. Think of this in terms of stripes. Okay? In other words, what is our function when x is less than 0?
Be negative.
What's the function? Right there.
X squared.
Here's the function. Here's the domain. Or in other words, this is the horizontal axis. This is what the graph looks like. Well, what does y equal x squared look like?
It's a parabola.
With its vertex at
0.
Okay, so I'm going to draw this thing like this. Now what goes here, a circle or a closed dot?
Be a closed dot.
When it's less than, it's open.
Oh, open.
To get a closed dot, you have to have that or this.
Oh, okay.
So it's open dot based on the fact that it's less than 0 only. Okay, now the next region we want to pay attention to is from 0 to 2. Well, if we make this 2, that's this region here. Okay, what's our function in that region?
The function is...
What's f of x equal to in that area?
X.
Correct. What's that look like? What does f of x equal to x look like?
It's like a...
Straight line?
What kind of line? Yeah, straight line.
Straight line at what angle?
45-degree angle?
Correct. Slope of?
Wouldn't it be slope of 1?
Correct. That's what a 45-degree angle is a slope of 1. So I'm going to the rest of my curve, I can draw right like that. Now I have to decide what to put on each end of that piece. On the left end, open dot or closed dot?
That one would be closed, right?
Correct. So it changes that dot because that curve goes through that exact same point. In other words, both x squared and x are both equal to 0 at 0.
Okay.
So you don't ever have an open dot on top of a closed dot. You just have a closed dot. And then the rest of the area, you miswrote that. That is greater than or equal to 2?
Yeah.
Yeah, what goes on the right side of that middle piece, incidentally? Open or closed?
That would be open.
Correct. And that's at 2 because y equals x. And then the rest of the way, the function's equal to what?
Function is equal to -2.
Correct, which looks like what?
That would be, wouldn't that be, what's it called?
Horizontal.
Horizontal.
A horizontal line. And it is at -2. Well, there's -2. And it starts with a closed dot because that says, notice why that's not correct. If this function was the way you've written it, it wouldn't be a function because it would look like that and doesn't pass the vertical line test.
Right.
So it has to be, this is when x is greater than or equal to 2, and the rest of the function must go in this direction.
Okay.
And this part right here is y equal x squared. This part right here is y equal x. And this part down here is y equal -2. Even though you rarely see it labeled like this. I'm not sure why. I kind of like it. But
yeah.
I've never seen this in a book. I just made that up, where I label each part.
Right.
But
I always label it just in case.
Well, the fact is, this is what this graph looks like. Okay.
And so 49 would basically be the same
49,
thing, right?
And notice that 49 is correct in the sense that the domain goes from -infinity to 0, and then from 0 to 2, and then greater than 2. So I know there are not any mistakes over here, whereas up here it was real clear. This one went from -infinity to 0, 0 to 2, and then -infinity to 2. That can't.
Yeah, I probably
that would not be a function. So, this is a little different question. They don't want us to graph 49. They want you to find h of minus 2. What's h of minus 2 equal?
So h of minus 2
So
equals...
find minus 2 on the domain. Figure out which function is associated with that domain.
That would be the first one.
Negative 5.
Yeah.
What is h of 0?
H of 0, that would be the second one.
Okay, but what's its value? In other words, how do you get its value?
I don't know.
Okay, well, this is extremely important. Let's go over this. If h of x is equal to 2x minus 3, what's h of 0, and how do I get it? Plug in 0 for x.
Right.
That's
that would be negative 3.
That's what this means. When I put something other than x in the parentheses, it means you are to plug it in wherever you see x. So
oh, okay.
Correct. That's minus 3. But let's not leave this for a moment. What's h of 3 equal to? Hold it. That's different function. I think you get it, right?
Yeah.
What is h of 4 equal to?
H of 4, that would be x squared.
Okay, and now what's h of 4 equal to? If the function is x squared,
that would be it's called 16.
that's what it's called. Okay.
Okay.
Word problem.
Yeah, it's from my notes. We did it in class, and I was kind of just unsure about it.
This is the quintessential algebra problem. And by that, I mean, if they were going to test somebody's algebra knowledge and they can only ask them one question, it would be something like this.
Right.
Okay, so there's the equation of the line. But they want the equation that is perpendicular to this.
Right.
And the perpendicular one goes through the point 2 comma minus 5. Well, when you're talking linear lines, straight lines, what's the most important thing about that? What single word is the most important? You've been working through Algebra 1, Algebra 2, and College Algebra. What's the most important thing about linear functions? Slope.
Slope, yeah.
Slope. In other words, all lines, the difference between that line and that line is primarily slope. Now, it's also nice to have a point that they go through, but if I can figure out the slope and a point, then I can come up with the equation of any line.
Okay.
So first of all, let's figure out the slope of this line. How are we going to do that?
So that's where I get stuck.
Put it in. What's the one format that you know for lines?
Y equals mx plus b.
Okay, so that's the form we want to get it into, because if we can get it into that, that's the slope. And we can just read it.
Right.
So let's transform this equation into y equal mx plus b, then we'll know what the slope is, and then we can take the next step.
Okay. So would you subtract 3x from both sides?
Okay. And I'm going to put it in front instead of in back because I want it to look as close as I can to that.
Okay.
See that? Now I got it close. I got some number times y equals mx plus b. Well, what's the next step?
The next step is to get y by itself.
Okay, how do I do that?
So you would divide by 7.
And that means dividing each term by 7.
Right.
Now, what's the slope?
Wouldn't the slope be 6, 7?
Look up here. The slope is the number that is the coefficient of the x term.
Oh, so it'd be -3/7.
Correct. So that's the slope of this line. But they want the equation of a line that's perpendicular to this line. So what is the slope of our perpendicular going to be? If the slope of this line is -3/7, what's the slope of any line that's perpendicular to this line?
Would it be like the opposite?
You have to do two things. Reciprocal? Opposite, reciprocal. You said both things. Always remember you have to do both things. Never just one thing. So what's the opposite reciprocal?
Wouldn't it be m equals -7/3?
Well, that's the reciprocal. What's the opposite? In other words, it really is the negative reciprocal. So it's got to be +7/3.
Okay.
Okay? In other words, you have to not only flip the fraction, but you have to change the sign. Whatever the sign is, just change it. So opposite reciprocal actually is the better than negative reciprocal. And this little sign here means this is the slope of the perpendicular, not this line here. Okay? So now let's talk about this perpendicular line. What do I know about it? In other words, if I want to write it in this y equal mx plus b format,
right.
What do I know?
You know that y equals -3/7.
No. We're talking about the equation of the line perpendicular, so we're going to start here.
Okay, so y equals 7/3.
X plus b. I know that much about coming up with the equation of that line. Now they also tell me that this new line goes through this point. What is that going to allow me to solve for?
That allows you to solve for b.
Correct. So how do I do it?
You're gonna plug 2 in for y.
Okay, give me the equation.
2.
No.
Y.
Look at how I've labeled them. First number is the x coordinate. Second number is the y coordinate.
Right. So -5 equals 7/3 times 2 plus b.
And notice that I can now solve this for b.
Right.
Once I solve it for b, I'm going to go back in and put it right there, and that's my equation of that line. In other words, the final equation of the line still has a y and an x, but you solved for m and b always. If you have m and b, there is only one line that represents that. There's no other line. Once you come up with m and b. Okay, now let's make sure you can do this algebra.
So that would be -5 equals 14/3 plus b, and then you're going to subtract 14 thirds from both sides. And
what's that number equal to?
that would be...
It's not an easy one to get off your calculator. Well, you can try, but it's not going to be that easy.
Right. So...
How do I do this mathematically? If I didn't
have a denominator?
Yes, if I didn't have a calculator, I'd have to come up with a common denominator. What's the common denominator?
3.
Okay. How many thirds? How many thirds is minus 5?
That is negative 15.
Uh-huh. That's the same as minus 5, and that's what's important, is that I not change it.
Right.
Now,
minus 14.
What's the answer to minus 15 thirds minus 14 thirds?
That would be, let's see, negative 29.
Uh-huh. And you should leave your answer as that. Don't convert it to a proper fraction. So minus 29 thirds is what B is. So now all I have to do is go back up. Here was the equation of the line that had everything but B. Well, we'll just substitute minus 29 thirds for B, and there's our answer. So this was a great problem, because first of all, you had to manipulate that to get it into y equal mx plus b format, so that you could figure out the slope of this line. Then you had to know that the perpendicular was the opposite reciprocal, so you could figure out the slope of that line. And that gave you that equation. And then you had to figure out what B was, because only this B is going to go through that point. If you wanted to check it to see whether or not you really had the right answer, I would plug this point into this equation to make sure that it was a true and valid equation.
Okay.
In other words, I would do the following math. I would plug in minus 5 for y equals 7 thirds times 2 minus 29 thirds. Well, this better be correct, because this is how we got the first one. In other words, this is always going to be correct unless we did an arithmetic error the first time through.
Right.
But you'll find that that is true. All right. Okay. So every part of that problem was key to know. That's why it was such a good problem. All right. Let's. This is 69. We want this one next or the other one?
Yeah, that works.
Okay. And these are just graphs.
Yeah.
Now, basically, there's a bunch of ways to do graphs. In the hard way, if your life depended on it, you just make up a table of x values, plug it in, and see what the y value was, and then plot those points and connect the dots.
Right.
Right? But that's not really the most efficient way to do it.
Right.
The most efficient way to do it is to take it as a translation of the elementary function.
Right.
Which means you have to know how all 10 elementary functions look. What's the elementary function on number 1?
Isn't that a quadratic?
No, it's y equals square root of x. In other words, here's the elementary function. What's different about this function? Oh, and incidentally, let's graph the elementary function.
Right, okay.
All right, in other words, x has to be 0 or greater, and y is always going to be positive. So it never goes to the left of the x-axis, and it never goes below the y-axis. And this is a closed dot because x can be 0. Remember, I'm graphing this function here, the elementary function. So what is happening to this function? What is different about this function from the elementary function?
You're going up, so wouldn't it be a vertical shift?
It's a horizontal shift.
A horizontal shift.
And the reason is that the adjustment comes inside the function, not outside. In other words, if I wanted to do a vertical shift, I would write it like this.
Okay.
That's outside the function. But if I put it inside the function, it becomes a horizontal shift. In which direction?
To positive 4.
Negative 4.
Negative 4?
Yeah. Kind of think about all your things involving x and h. Okay? Vertex format of a quadratic was x minus h, quantity squared, times a plus k. X minus h. Think of your conic sections. X minus h squared plus y minus k squared equals r squared or 1, depending on whether it's an ellipse or hyperbola. My point being that every time you see an x and an h, it's always subtraction going on.
Okay.
So the standard is x minus h, which makes h a negative 4.
Okay.
You see why?
Yeah.
In other words, it basically becomes the opposite of whatever that sign is. So h is negative 4, so which way do I horizontally shift?
So the negative 4, so to the left.
To the left. Okay. Now, there's a really easy way to determine whether you shifted correctly or not. And that is that we know there's some pretty good domain restrictions here. Can x be negative 4?
Yes.
Yeah. No, it can't.
Yeah.
If this was reading x minus 4, then x would have to be at least positive 4. So if I was graphing y equals square root of x minus 4, I know that I can't not have an x less than 4, otherwise I'm going to be taking the square root of a negative number. So I would know I would have to move it to the right. So those little checks you can always make.
Okay.
In other words, to figure out where this function has to start, determine whether or not it can be equal to minus 4. Yes, it can. Can it be less than minus 4? No. If I wanted to make x minus 5, I'm outside of my domain. Okay? What's the elementary function in 2? I'm going to write the elementary function as a little f of x, and all these are capital F of x's, so.
That would be equals like the lines. I don't know what they're called.
Absolute value.
Absolute value of x.
That's it. That's the elementary function. That looks like this. Remember, whenever you see absolute value, know that you're going to have some sort of a v.
Okay.
Okay? In your graph. So what I've graphed there is this.
Right, okay.
Two things are happening to this in the way of adjustments. What are they? What's going on inside the function?
With the original one or that one?
Well, what we're doing is we're comparing this function to the parent function.
Okay.
There's two things that are happening. We're subtracting 2 inside the function, and we're subtracting 2 outside of the function.
Right.
The consequences of this minus 2.
It's going to turn into a positive.
Which way does it? It's a horizontal shift.
It's going to go to the
left. Is that what you said?
Yeah.
So that first adjustment forces that picture. Now what's the result of this minus 2 outside the function?
You're going to go down 2?
Correct. So here's our final answer. I did it in pieces only to illustrate. You can do every one of these changes one at a time.
Okay.
Okay. What's the elementary function? You tell me whether you want to go through each one of these or just the orange ones.
We can do...
2 and 6 are almost exactly the same.
Yeah.
Let's do, just tell me 3. I won't even graph it. I'm going to ask you questions about 3. What's the parent function?
The parent function would be y equals square root of x.
What's going on inside the function? Tell me horizontal one way or the other, or vertical one way or the other.
Right, and it's going to be it's going to be at, it's going to go to the right.
No.
Wait, no, where am I? Okay, it'd go to -1 and start at negative.
It moves right. You're correct. It goes left by 1 unit. That's how you describe that. Left by 1 unit. What's the consequences of that -1?
It's going to go down 1.
Correct. And is this a negative sign or not?
No, that's the...
If that were a negative sign, that's a third thing. That's another thing you can do. That would be a reflection over the x-axis. Always do your reflections first before you do any of the 4 possible adjustments, because it matters. If there were negative signs anywhere in front of the x's or the function here, we would want to make sure we did those reflections before we did all these adjustments. Okay, what's the parent function on 4?
4, the parent function is f of x is equal to the absolute value of x.
Okay, and what 2 things are happening? What 2 transformations?
You're going to go to the left to...
What's h here?
That's going to be positive, so...
What's h?
H is 2.
Positive 2.
Positive 2.
And a positive h means you go to the right, a negative h means you go to the left.
Right.
Up here, h was -4.
Right.
Because the standard is x minus h. So if I'm looking at x plus 4, h has to be a -4. Okay? And what else is happening on 4? So we're going to the right 2 units, and just take your vertex and move it. And what's the consequences of that?
You're going to go up 1.
Okay. Yeah, I think you got those down pretty good. Let's go to 2.6. Now, these get a little more complicated. Interesting. What do they want us to do here? On 35. I'm not convinced you wrote this right.
Yeah, hold on.
There's no y. In other words, I can solve this equation, and I'm going to get 2 possible answers for x, but that doesn't allow me to plot it. That's just 2 vertical lines.
Right. Let me double check real fast. That is problem 35, right?
Oh, maybe this is not graph it, but solve it. Yeah. No, I don't see any directions saying graph. The previous section was graph them. Okay, so what we're doing is solving this. That's okay. That was my fault, not reading. So let's solve this equation. Where am I going to start? I want the very last line to read x equals something.
Right.
Or something else. Whenever you have absolute values, you usually end up with two answers for x. It's kind of like a quadratic. Most quadratics, when you solve it, you get x equals this or this. Same thing with absolute values.
Okay.
Okay? But the very first thing we want to try to do, if we can, is get it so we isolate the absolute value. Something inside of there equals some number. Then we'll be able to go forward. Okay? So this is the part I want to isolate. So what two things do I need to do first before that's isolated?
You need to take care of what's in the parentheses
I have
first.
to take care of, no, everything outside.
Right.
In other words, I need to get rid of this plus 1, and I need to get rid of this 1/2.
Okay. So you're gonna.
How do I get rid? What's the first thing I want to get rid of? Which one? The plus 1 or the 1/2?
Doesn't matter.
Actually, it does. And you'll see why. Let's get rid of the 1 first.
Okay.
Okay? If I tried to get rid of the 1/2, I got to multiply everything by 2. Which means I'd have to multiply that by 2, I'd have to multiply that by 2, and I have to multiply that by 2. If I get rid of the 1 first, by subtracting 1 from both sides, well, now the next line is this. I got rid of the 1.
Okay.
Now, to get rid of the 2, I only need to multiply the left side by 2, which completely gets rid of it, and the right side by 2, which turns it into a 6.
Okay.
So now I have this. And what's my next step?
You're gonna do 2, so it'd be 3x minus 2.
Can I get rid of that inside parentheses?
No.
Actually, I can. In other words, I can do all operations that I want inside the absolute value signs. So I want to get rid of that parentheses and simplify that expression. So
that's what I meant.
So do that. Get rid of the parentheses and then simplify the expression. What do you end up with?
Well, that would be 6x minus 2 minus 3.
Now simplify that.
So that would be absolute value of 6x minus 5.
Okay. Now we're in business. And we didn't do anything to the right side. I was just simplifying the left. Okay, now here's a really important point. If the absolute value of x is equal to 7, that means two things. What are they? Either x equals or x equals what goes here?
Positive 7 or minus 7.
And you can always say that, regardless of what's inside the absolute value. If that was x minus 10, then I would say x minus 10 is equal to 7, or x minus 10 is equal to minus 7.
Right.
Okay? So this is a very important concept, and it can apply to our problem So what two statements can I make? Never change what's inside the absolute value when you're doing it. So the first thing always is whatever's inside that is equal to something.
Okay. So
What's it equal to?
6.
Or, and there's always an or, again, never change what's inside the absolute value. A lot of people try to. What's that equal to?
-6.
Okay, now let's solve each equation. We're going to come up with our two answers.
Okay, so then you're going to add 5 to both sides. And divide by 6, and that'd be 11/6. And then that one would be x equals -11/6.
When I add 5 to both sides, that.
Oops, yeah.
Don't make the mistake of assuming that it's going to be this same number. It never is.
So then you divide by 6, and then x equals -1/6.
So there's your 2 points. Those are your two answers. If you plug either of those values into the original equation, it will be an equation. It will stay this equation. In other words, it will satisfy that equation.
Okay.
But that's how you do it. You have to isolate the absolute value. If you can simplify inside, do so. We did so there. And once we get to this step, we've isolated the absolute values. Now we can go to our either-or statement.
Okay, that makes sense.
That's the process you want to use every time. And it works for inequalities also. There is one difference on the inequality. I'm going to cover this. If I say the absolute value of x is greater than 6, what two things does that mean?
X is
the first thing is always exactly what it says, only without the absolute value sign.
Right.
So you can immediately write the first thing by just removing the absolute value sign. Now what's the other? What's the or?
That would be or x is greater than or
This is where there's one more additional step. You have to change the direction of the inequality sign.
Less than or equal to?
And change that.
Oh, okay.
So when you're doing the second part, there's two things. It's almost like an equation, but you change the direction on the or part also, in addition to the sign of the right side.
Okay.
Okay?
That makes sense.
I don't see any problems on here like that, but we may come into one. Okay, now we're getting difficult here. I think we'll have just about enough time to do this. I got to figure out how to do it first of all. Well, I know how I would do it. Let's do it exactly the way we've been doing it.
Okay.
Okay. So what's the first statement I can make?
5y plus 8 equals
Don't change.
absolute value
Right.
2y 3.
Okay. Or
5y plus 8 equals
where's the negative sign go?
On the outside. Absolute value of 2y plus 3.
Now notice what we're looking at. Now we've gotten rid of two absolute value signs, and each one of these things only has one. So now we can write two equations for that, and two equations for that, and we're going to end up with 4 answers. So what are the two equations I can write over here? In other words, we're dealing with this part right there. Solve that as if it were a problem all alone.
Okay, so then it'd be 5y.
Hold on. Start with what's inside the absolute value marker. Always start there. And just to be consistent, I would always put it on the left. So the first thing I'm going to write is 2y plus 3.
Okay.
Equals 5y plus 8. Or
it'd be a negative 2y.
no, never change what's inside the absolute value markers. Never.
So it'd be 2y plus 3 equals to negative 5.
The negative of that. What is the negative of that?
Minus 5y minus 8.
Correct. Now, we can solve that real easy. I got 7y equals 11. Y equals minus 11 sevenths.
Okay.
Now, didn't do this part. I got to solve that also. What screwed me up here is that I'm used to putting my or sign horizontally because each of these things need to be solved vertically. I didn't have enough room on the paper to do it here, so I went down and I forgot to solve this one. What is the solution to that first one here, where the check marks are? What is y?
Y is equal to, let's see here, why can't I think right now?
Well, let's talk about this. Am I going to take my y's to the right and my numbers to the left, or am I going to go the other way around?
I normally do put the y's to the left.
What's probably more useful is if you do it in the direction that's always going to leave a positive coefficient on the y term.
Okay, so then I subtract 2y.
Yeah, that leaves me with 3y over there, not a negative. If I move 5y to the left, then I've got negative 3y. Okay? If I moved my y's to the right, I got to move my numbers to the left. So y equals minus 5/3. Notice no resemblance with this answer at all.
Right.
All four numbers are different, as they almost always are. Now, over here, we still have two more solutions to come up with. Got to solve that one. That's a completely whole nother problem. What's the first thing to do?
First thing to do is that I would move the absolute value sign.
Well, remember, we're trying to isolate the absolute value. We want something equal to something else, like that. Well, the absolute value sign is fairly isolated. What do I have to do to make it all on its own?
Would you do 5y plus 8 equals minus 2y plus 3?
No, you can't distribute that negative sign inside an absolute value marker like that. But what I can do is divide both sides of the equation by minus 1. So I get minus 5y minus 8 equals, now I got my absolute value all isolated. Okay? Now you can solve this like every other problem we've been doing. In other words, this is going to give you an either or. Either 2y plus 3, and it's not even an either or, it's an and. It's not even an or. Well, I guess it's an or. But so I'm going to be able to say 2y plus 3 equals minus 5 minus 8. Solve that. Or 2y plus 3 equals the negative of that, which is 5y plus 8.
Oh, okay, that makes sense.
And then that's going to give you a third solution, and that's going to give you a fourth solution. And that makes sense. Whenever you have two absolute value signs in the same equation, it's particularly, this is a tough problem. You're going to have most of your class not be able to get this one, just because it involves 4 layers. In other words, you end up with 4 solutions because you have when you have just one absolute value sign, you end up with 2 solutions. When you have 2 like this, it's difficult to get rid of one of them. You saw what we had to do.
To solve them?
Yeah, to solve this one. In other words, you get rid of one at a time.
Right.
This was the way we got rid of one. And then we had 2 of these equations, and we solved each one of them to get rid of all of them.
Right.
And I noticed that 43 is just like this, only harder, because it's got all these fractions. But I'm going to solve it exactly the same way. In other words, you say whatever's inside there is equal to the entire right side, including this absolute value sign, or it's equal to the negative of the right side. So then we have 2 equations, each one of them having only one set of absolute value markers. And then we'll be able to solve it.
Okay. Got it.
Okay. That's a good session today.
Right. And my dad wants to, and I want to, go to 3 days a week. He sent me an email.
Yeah. What third day works best for you?
So
2 o'clock, you can have your choice.
Okay.
It's the advantage of being in California as opposed to Denver.
Right. So on Mondays and Wednesdays, I don't get back home until around 1 my time, and that's 2 your time. So I wouldn't, and plus finding parking is a little difficult.
Okay. What's the optimum for you? What's the perfect day and perfect time that would work for you for the third session?
For the third session?
For the third hour?
Probably
we could
Wednesdays.
Okay. At what time? I can right now. I can fit you in Wednesdays. I'm pretty open on Wednesdays.
Okay.
2:30 or 3, you can do that.
We could do 2 or 3. I'm trying to think like time difference wise.
Well, you can, Denver, let's see, California time, if we did 3 Denver time, that would be 2 to 3 California time.
Okay.
Does that work?
Yeah.
Okay. And you can always change it. Nothing's fixed in stone. So on Tuesday and Thursday, we'll still be at 2 o'clock my time. On Wednesday, we'll be at 3 o'clock my time.
Right.
Okay. Sounds good.
Perfect.
I will talk to you tomorrow.
Sounds good.
All right, Taryn.
Thank you so much.
Bye-bye.